Hi everyone, welcome back to Math Simplified by HM channel. Today we are taking a closer look at the fascinating topic of similar triangles. Before we dive in, please make sure to subscribe to the channel and turn on those notifications. We have already covered triple A, AA and SAS similarity test. So now we are going to explore our yes test of similarity of triangles. Grab a notebook, feel free to pause the video whenever you need to, and let's get started. A step-by-step geometric proof. Side, that is SSS similarity criteria or theorem. For a given correspondence of vertices of two triangles, when three sides of a triangle are in proportion to corresponding three sides of another triangle, then the two triangles are similar. This is the test and we have to prove it now. We will see its proof step by step. Let us break down the theorem statement in two parts, that is what is given and what we have to prove. Now assume that as per theorem statement there are two triangles ABC and PQR such that their corresponding sides are proportional. AB upon PQ is equal to BC upon QR is equal to AC upon PR. We have to prove that triangle ABC is similar to triangle PQR. Up till now, we have seen three tests of similarity. First one is AAA similarity, second one is AA similarity, and third one is SAS similarity. Using one of these similarity tests, we are going to prove SSS or triple S similarity tests. For this, we need a little construction. Let us assume that triangle PQR is larger than triangle ABC. Then mark point M on side PQ and point N on side PR such that PM is equal to AB and PN is equal to AC. Then draw a line segment MN. Here we observe in this triangle PQR side QR is seems to parallel to segment MN, but we have to prove this first. We are given the proportion AB upon PQ is equal to AC upon PR. Substitute our constructed lengths PM for AB and PN for AC. We get PM upon PQ is equal to PN upon PR. See in diagram, triangle PQR, we have now PM upon PQ is equal to PN upon PR. Now, by the converse of basic proportionality theorem, because the line divides two sides in the same ratio, it must be parallel to the third side, and thus we have get segment MN is parallel to side QR. Let us name this statement as 2. Now we move to step 2 to prove MN is equal to BC. Now we have found that segment MN is parallel to segment QR. Corresponding angles are equal. Thus, angle PMN is congruent to angle Q and angle PNM is congruent to angle R. Thus, triangle PMN and triangle PQR are similar by a similarity test. Since they are similar, their sides are proportional. So we get Pm upon Pq is equal to Mn upon Qr. Name this equation as 3. But we originally given AB upon PQ is equal to BC upon QR. Since we have PM is equal to AB, this means PM upon PQ is equal to BC upon QR. Now compare equation 3 and 4. Its left hand sides are equal. So their right hand sides Mn upon Qr is equal to Bc upon Qr. Again here denominator is same. Therefore their numerators must be same. We get Mn is equal to Bc. Name it as equation 5. Now we come to the final conclusion step. Now look at triangle ABC and triangle PMN. We have established AB is equal to PM and AC is equal to PN by construction, and BC is equal to MN. Just we have proved equation 5. Therefore, triangle ABC is congruent to triangle PMN by SSS congruence test. Since congruent triangles have equal angles, we get angle A is congruent to angle P, angle B is congruent to angle PMN, and angle C is congruent to angle PNM. Substituting the angles from step 2, we get angle A is congruent to angle P, angle B is congruent to angle Q, and angle C is congruent to angle R. Thus, triangle ABC is similar to triangle PQR by AAA similarity test. Hence, we have proved the SSS test of similarity. Thank you. May the beauty of geometry continue to inspire your mind and shape your logical thinking. Keep exploring the wonderful world of mathematics. Thanks for watching. Before you go, please share this with your colleagues, drop a like and hit that bell icon. If you haven't already, make sure to subscribe so you don't miss our upcoming videos. Have a great time.